All right, the first thing we're going to look at is conditional probability. And if you noticed here in this two-way table, we're talking about pierced ears. If we know that a randomly selected student has pierced ears, what is the probability that that student is male? And that's what we're going to explore today is conditional probability given a certain condition. So for instance, if we look at this right here, we want the probability that the person is male given that they have pierced ears. So this is the question we're looking at, this one right here. So the probability that someone is male given that they have pierced ears. Now if you notice in this case, we're going to look at this column. Okay, so it has a condition that someone has to have pierced ears. So when we look at this, notice that these people that are male have pierced ears. So that's 19 out of 103. Now the next thing we're going to do is the next one, which is the probability that someone has pierced ears given that they are male. Now this is slightly different, so we're going to take these away, these highlighted areas. Now the probability or the condition in this case is given that they are male. So we're going to look at this row, and then we're going to look at the probability that they have pierced ears, okay, or that they have pierced ears, and that's going to be this right here. So 19 out of 90. Now notice that these two are not the same. All right, this one right here and this one right here are going to give you different probabilities. All right, now let's look at the next page. This is what we call a conditional probability, and the way we read it is the probability that someone is male given that this vertical piece right here has pierced ears. That little thing means given. Now you have two events. Event A is someone who has pierced ears. Event B is someone who is male. So the way we write that is this: the probability of B given A. So the probability that someone is male given they have pierced ears. Always write it in this condition, okay? Let's go back to a pen here. So make sure that this is the way you're writing your probabilities, especially conditional probabilities. All right, now we're going to talk about conditional probability and independence. When you flip a coin, or when you flip a coin twice, the first toss, the probability is 1/2. But when you flip a coin the second time, it doesn't depend on the first time. So it is what we call independent. Now, the way we write this is, what is the probability that flipping ahead the second time, that's this right here, flipping ahead the second time, given that you flipped ahead the first time. Because tossing a coin is independent, that means it has no memory. The second toss will have a probability of 1/2. Now, since that is the case, we can use these two formulas. Since the probability of probability of B given A is going to equal the probability of B. In other words, because A is independent, it doesn't determine what the probability of B is. Therefore, the answer is going to be probability of B. If you reverse that and say, what is the probability of A given the probability of B, well, that's going to give you the probability of A. That's only if these two events are independent. Okay? Let's go over this one real quick. This shows non-dependent, or this actually is dependent. If you have two dice, and the first event you want to roll a 4, and the other one you want the sum of the dice to equal 11. Well, the probabilities are 1/6 and 3 out of 36. So you have a probability of rolling a 4 1 out of 6 times, and your probability of rolling an 11 3 out of 36 times. And now you want the sum of two dice is given, or the sum of two dice given that the red die is a 4. Now, because we've put this condition on it, if I were to roll a 4, that's this right here, it would be impossible to get a sum of 11. Therefore, the probability of this happening, the sum of two dice equaling 11, given that I've rolled a 4, that probability will be 0. All right? Now, I wrote a little thing here. I'm not sure if it really makes much sense, but this conditional probability is different from unconditional, such as the probability of the sum of getting two dice to get rolling two dice for an 11. So conditional versus unconditional. Okay, there's no condition on this one. And I think that is it for, oh, last thing, events RS. So this is rolling a 4, and this is getting a sum of 11. Can't happen together, therefore they are mutually exclusive. All right? This means if one happens, the other is guaranteed not to happen. Make sure you understand that. So, in a nutshell, two mutually exclusive events can never, ever, ever be independent. Now, don't confuse independent trials with independent events.